Hi viewers, welcome to LMS Solution. In this video, we are going to see about how to detect fault and classify the fault in distribution system as well as transmission line by using support vector machine. So this is one kind of algorithm. So how we can use in MATLAB. So first we are going to discuss about what is support vector machine. The support vector machine is one kind of supervised learning. So that going to be used for classification as well as recursion task. That means if you have input data set and the target data set, so when you feed this input and target data set, it can be used for easily classify that target as well as it will be easily apply that regression for that particular data set. How that support vector machine is work? So it will be create hyper plan for between that more than two classes. For example, you consider this picture. So it having two classes. One is red color one, another one is blue color one, and then it going to be create the hyper plan between two classes. See here you see that. So this is a hyper plan for the first class, and then is a hyper plan for so this is a decision boundary. Okay, so it will be create the hyper plan for that each classes. So after creating that hyper plan, next it will be find out the decision boundary, closest decision boundary. So that decision boundary is going to be considered as a support vectors. So that will be going to be help to classify or apply the regression task for the your input and target data. So next option in the support vector is kernel. Okay, that means it have different kind of function like polynomial function, radial basis. So when you use this kernel option, right, you can easily classify them and nonlinear class sets. Okay, so this is biggest advantage in the support vector. And then next you got to, if you choose C value, right, if you tune that C value and kernel value, gamma value, then you can easily tune that SVM to classify the system or find that mean accurate result, okay, from that your input and the target. So this is about that 5 points about support vector machine. So one is supervised learning, and then it going to find out the hyper plan for the classes. So next it going to find the decision boundary, closest to decision boundary. So that is known as support vectors. And then it have two kind of parameter. One is C parameter and a gamma. Okay, so if you adjust this value, then you can tune that SVM effectively for getting the better. So next move on to the application. Now we are going to apply that support vector machine to detect the fault and classify the fault in the process. Okay, so for that we need to collect the data. So here you see that, right. So this is a collection. The first step in the fault detection and classification is data collection. Second step is after data collection, the second step is training the data set by using support vector machine. And then after training process, you take that support vector machine for classify and detect the fault in the simulation model. So there are three steps. So one is data collection, second one is training, third one is application of that trained SVM in the simulation. So first you discuss about that data collection. So first we need to create the different model for normal operation for different faults, right? AB fault, ABCG fault. That means there are different kind of fault is there. That means single line fault, double line fault, triple line fault, and then double line to ground fault and the triple line to ground fault. So you have to create that all possible fault in the system. That means by using that simulating model, right? So you have to create this kind of simulating model. That means you have 11 kilowatt source, and then it have 11 kilovolt to 400 volt transformer, step down transformer, and then here we are load, here we are having load, right? And then in this point we are applying the fault. So in this point we need to create the different type of fault like single line to ground fault, double line to ground fault, double line fault, triple line fault, and then triple line to ground fault. And then you need to collect the data. So you need to collect the data of voltage, current, and then you have to collect the zero sequence voltage. So in order to collect the data, so this is, we have this code. Okay, so you have to run this code. So when you run the code, you will get the data, x data and d data. Okay, So already we run the code, so we have the data set. So this is x data, so collected data for different faults, and then this is d data. So d data is named as labeled data or target data. So this is a classes. Okay, so next to process, so this is the first process is collection of data, that means x data, input data and a target. So second process will be going for a training. So for that, go to apps, comes to classification learner and click new session, click from workspace. Now select input, so input is x data. Now click from workspace, target is d data or labeled data is d data. Now the cross validation fold will be 5, we are selected now. So click start session. Next select find Gaussian SVM support vector. So next train all, click train all. So now the training process will be going on. So now you see that, right, after completion of training, right, so you will get accuracy of around 96.7 percentage. So this is a confusion matrix between true class and predicted class, and then this is scatter plot. So this is ROC plot for the different classes. So ROC for the different classes. So this is a parallel coordinate, that mean graph between standard deviation with respect to number of features. So this is a result table of the support vector machine. So here you will see that accuracy is around 96.67 percentage. So these are the detail you can get from the training of support vector machine in the MATLAB. So next you have to store this trained SVM in the workspace or in the .mat file. So next step is we are going to use that support vector machine in the Simulink model. So here you see that, right, we are calling that the support vector machine trained function, right, via this interpreted MATLAB function. So it going to be receive inputs VA, VB, VC, IA, IB, AC and V0 and I0. The output will be classes. Okay, so these classes will be going to given the classification decoding logic. So from that you will get the detection and classification details. So now I am going to explain the system with the different fault condition. So here you can see the result of the source side voltage and current. Okay, and then here you will see that so this is also source side voltage and current and fault detection logic, that means output of the fault. Now I am going to create no fault. Okay, so now I am applying no fault in the system. Next I am going to check the results. Now run the model. Now see this, there is no changes in the any classification scope, right? So everything will be maintained at 0. If it is 0, there is no fault in the, and also you see that, right, source side voltage and current. So there is no changes in the voltage. So next I am going to change the fault to A to G fault, and then I am going to run the simulation. Now you see that, right, the fault is detected at this time and fault is classified at this time, right? You will see that, right, fault is classified at a G fault. Okay, and also you can see the variation of voltage. So this is a source side voltage and current variation and also detection logic. So this is RMS voltage and current variation in this source. So next I am going to change this fault is BCG fault and then run the model. Here you see that fault is detected, and then here you see that, right, fault is classified as a PCG fault. Okay, and also you can see the variation of source voltage and current, fault detection logic, RMS voltage of source side and RMS current of the. So next I am going to make ABCG fault and then test the system. So fault is detected, the fault is classified as a ABCG fault, and then source voltage and current variation, RMS voltage and current variation. So this is a fault detection. So from this testing of simulation model, so we can conclude that the support vector machine is efficiently detect the fault and classify the fault and the distribution line. The same kind of method you can apply in the transmission. So that's all about this video. Thanks for watching our videos. So kindly subscribe our channel and also click bell icon for notification about upcoming